Welcome, student. Today I am going to discuss the my previous topic. Actually, due to network issue, it is disconnected. I am again discuss this topic: balancing of a single rotating mass by the two masses rotating in different planes. Okay, so we already discussed in previous video lecture what is the static balancing and dynamic balancing. What is static balancing? If the algebraic sum of the all forces about on a rotating shaft is equals to 0, that we can say it is a static balancing. If the all summation of all algebraic forces as well as all algebraic moment will also 0, then we call dynamic balancing. So we can understand by taking example. Okay, this is a shaft which having the mass, disturbing mass m. Okay, there is a two plate L or M, okay, and A to be balanced by the rotating masses. M1 and M2 are different plane L or N as shown in figure. Let small r is the radius of rotation for the masses in plane A. R1 radius of rotation for the masses in plane L. R2 be the radius of rotation for the masses in plane M respectively. Okay, you can see in this space diagram R and R1 and R2. Okay, this is disturbing mass, these are the balancing mass. Okay, what is L1, L2 or L? L1 is distance between the plane A and L. You can see in this figure, this one A, this one L. So distance between both, and same L2 between A or M, and L distance between plane L and N. I hope you will understand. Now, now, it is same as previous. MC equals to MR omega square, FC1 M1 R1 omega square, same FC2 M2 R2 omega square. This is the first equation. Disturbing the summation of the disturbing mass is balancing mass is equals to the disturbing mass centrifugal force. So we can calculate this condition, that is represented by the equation number 1. Now in order to the magnitude of the balancing of force, the plane L or dynamic force at the bearing Q of the shaft, we can take a moment Fc1 into L equals to Fc into L2, m1 omega square r1 r. We put all the values and we got this equation. m1 r1 L equals to m2 r2 L. So you can see that the quantity of the balancing equals to m1 r1 equals to mr L2 by L. So it is depend upon these equation. We can calculate any balancing mass for maintaining a disturbing mass. Okay, same, let us take the second case in this. When the plane of the disturbing mass, one end of the plane of the balancing mass. Okay, so this is the similar figure, but something is difference. We can see there are disturbing mass act on one end and balancing by the between and one end masses. So you can see the distance as previous. What is L1? What is small L1? Small L1 is the distance between the plane L and A. Small L distance between the plane L and M, and L2 between A and M also. You can see in this space diagram the same thing. The following condition must be satisfied. We already discussed about in the previous Fc plus Fc2 according to this space diagram or systematic diagram. Now to find the balancing force in the plane L, then Fc1 L Fc into L2 mr omega square, that's why Fc2 L Fc into L1. So you can got these two equations by the help of algebraic sum of forces and the sum of moment. Okay, so I hope you will understand the both cases. It is very essential for doing any numerical problem. Thank you so much. If you have an issue and doubt, you can talk to me or call me. Thank you so much.